Good afternoon, Science 10s, or good morning, Science 10s. I don't know when you're watching this video. Oh, that's okay. We're going to talk about single replacement reactions today. And single replacement reactions are all about when one element reacts with a compound to produce a brand new element, an element that used to be in that compound and is no longer in that compound. So one element, basically, it kicks out one of the elements in that compound, and so you get a new element and a new compound. Perfect. Single replacement reactions involve the swapping, right, the trading of either a cation. How do we know a cation is positive? Because cats have paws. You can't see me doing the paw motions, but that's fine. I am, trust me. So a cation is positive and an anion is negative. Let's take a look at a very particular single replacement reaction. It's pretty interesting. So I took a time-lapse video of one, and I'm just going to set it up, and I'm going to show you what happens with this video. So in the demo that we're about to see, what we're doing is we're taking copper and we're putting it in a silver nitrate solution. And so the copper, is a metal, and it's going to kick out the other metal, right? So the metal kicks out the metal, or the thing that could be a positive ion kicks out the positive ion. So the silver gets kicked out and the copper takes its place. So we're going to get silver and copper to nitrate. So let's go ahead and watch this video, and I'm going to talk a little bit more about single replacement reactions after we watch the video. Okay, hopefully that was an interesting video at least. You should have seen, we stuck the chunk of copper into the beaker, and then we poured the silver nitrate on top of it. And hopefully you were able to see slowly over time. I mean, that took about an hour to happen, but slowly over time, you could see those silver crystals growing on the copper strip. And I don't know if you saw, hopefully you did, but there was a color change in our solution, and our color change was because of the copper 2 ions. Those copper 2 ions in our solution, copper 2 nitrate, copper 2 ions are blue in solution. And so you can see a copper solution from a mile away because it's often blue. So let's get back to figuring out some different single replacement reactions, and then we'll work on some examples of it. So just a couple things to keep in mind when we're talking about single replacement reactions. When predicting single replacement reactions, try to identify if the element that you're starting with, if it could turn into a positive or a negative ion, a cation or an anion. So let's try this out. So we've got magnesium metal, right? That's an element, reacts with hydrochloric acid, or HCl. Oops. So let's try this out. Our word equation, magnesium reacts with hydrochloric acid. And let's see, what's the magnesium going to kick out? Is it going to kick out the hydrogen or is it going to kick out the chlorine? Which one of these can act? I mean, keep in mind, magnesium, it's neutral right now as an element. It's neutral right now, but it could act as a positive ion or a cation. So it's going to kick out the other cation in here, the hydrogen ion. Let me show you, let me prove to you that the hydrogen can be a positive ion. I mean, for sure, the chlorine cannot be a positive ion. Here, I'm just going to look for the periodic table. So when we go in here, right, chlorine can act as a positive or a negative ion. Well, it can only act as a negative. Magnesium, the positive is not going to kick out the negative because positives are attracted to negatives, right? So let's see. I know hydrogen's up here as a negative, but the hydrogen 99% of the time is acting as a positive ion if it's with a negative thing. So yeah, the magnesium, this positive thing, is going to kick out that positive thing. Now keep in mind that magnesium is not actually positive right now. It's neutral. But anyways, whatever. We're going to get, so now we're going to get magnesium chloride. And we're going to get hydrogen all by itself as an element. So we're just going to get hydrogen gas. Okay, so as always, let's take these names and turn them into formulas, right? Magnesium, Mg solid. Hydrochloric acid, they tell us, right? HCl aqueous. It's going to turn into magnesium chloride. Magnesium is 2 plus, chloride is 1 minus. So MgCl2, and we can check our table of solubility and just see it's soluble. Oh, there we go. Just wait for it. So chloride is right here, and we'll go down, and I don't see magnesium, so it's under most. It is very soluble. Perfect. So right, aqueous. And then hydrogen is part of Hofbrinkel. Oh, that's a terrible hydrogen. Hydrogen is part of Hofbrinkel, so H2, and it's a gas. So let's go ahead and balance this. Let's balance this. 1 magnesium, 2 chlorines, 2 chlorines, 2 hydrogens, 2 hydrogens. Boom, done. Swish. Balanced chemical equation. Nice. So let's move on. Let's do a couple more. We're going to do this pretty quick. Complete the following one. Solid aluminum, okay, aluminium, reacts with copper 2 chloride, okay, copper 2 chloride, and it's going to make, well, the metal's going to kick out the metal, so we're going to get aluminium chloride. And we're going to get copper all by itself. So let's turn this word equation into a chemical equation. What's the formula for aluminium? It's Al solid. What's the formula for copper 2 chloride? Well, copper 2 is 2 plus, chloride is 1 minus. And you can see that in your periodic table, right? Chloride forms 1 minus ions here in element number 17, and copper 2, well, it says copper 2, so it's 2 plus. All right, no problem. So CuCl2, aqueous. It's saying a solution of copper 2, so we don't have to check. It's saying a solution, aqueous, copper 2. All right, no problem. So we're going to get aluminium chloride. Aluminium is 3 plus. Check your data booklet. Chloride is 1 minus. So AlCl3. And let's check our data booklet to see if that's going to be soluble. Chloride is right here. I look down. I don't see aluminum down here, so it's very soluble. Aqueous. And then what are we going to get? We're going to get copper all by itself. Cu solid. Perfect. So let's go ahead and balance this. 1 aluminum, 1 aluminum, 1 copper, 1 copper, 2 chlorines, 3 chlorines. So we're going to put a 3 here and a 2 here. That means we have 3 coppers and 2 aluminums. Perfect. That is our balanced chemical reaction. Last one, we'll just try and do this really quickly. Liquid bromine is added to a solution of aqueous iron 3 iodide. No problem. Let's do this. Bromine plus iron. Ooh, not iron. Iron 3 iodide. So the bromine, I don't know, is that a positive or a negative? I mean, it has no charge right now, but could it be positive or could it be negative? Let's look for bromine. Bromine could act as an anion. So it's going to kick out whatever the anion is, which is iodide. So bromine is going to replace the iodide, and the iodide is going to get kicked out. So we'll get iron, same thing, the iron hasn't been changed. Bromide plus iodine. Okay, no problem. Let's turn these words into formulas. Bromine is Br Hofbrinkel, Br2, and it said it was a liquid bromine. It's reacting with iron 3 iodide. Iron 3 is 3 plus, iodide is 1 minus. So we need FeI3, and it says it's a solution or aqueous. So we're going to get iron 3 bromide. Again, 3 plus 1 minus. So FeBr3. And let's go to our data booklet and check. I'm looking for bromine here. Bromine here. And I don't see iron 3, so it will be aqueous. And iodine, Hofbrinkel, absolutely. So I2 and solid. And we know it's a solid because we're checking our data booklet. Iodine is white, so it's a solid at room temperature. Perfect, no problem. So we've got our skeleton equation. Let's balance this. So 3 I's, I need 2 I's, so we need 2 of these and 3 of these. 2 irons, 6 bromines, so 3 times 2 is 6 bromines. Go ahead and pause it and rewatch it if that was a little bit too fast, but I think it's okay by now. We're hopefully getting pretty used to balancing equations. So that's the way you're going to do this. The metal kicks out the metal, the non-metal kicks out the non-metal. More appropriately, it's the potential cation kicks out the potential cation. The potential anion kicks out the potential anion. But that's, I mean, just try it out. Try it out if you can. So go ahead and try and balance these 5 or 6 reactions. Yep, 5 reactions. And go ahead and try to predict what's going to happen and try and predict these reactions. Let me know if you have any questions. The key and the notes will be posted as well in the instructions for today. So let me know if you have any questions. Office hours are 10:45 to 11:15. Thanks a lot, Science 10s. I'll see you later.